Thank you for that reminder. All right, so now the goal of GitLab, GitHub, and all this other organization is that they want to become that platform where you can run your CI/CD processes. If you look at this page, for example, it simply tells you what GitLab, for example, is trying to achieve. So they are trying to make sure that they become an all-in-one, all-encompassing a platform for whatever thing that has to do with DevOps. And so it tells you that GitLab is the most comprehensive AI-powered DevSecOps platform. So they are trying to, as much as possible, to make sure that you don't have to necessarily install several plugins. Because presently, if you want to use Jenkins, for every thing that you want to do on Jenkins, you have to install different plugins. If you want to interact with AWS, with Azure, you install plugins. Even for different sections of these cloud providers, you need to install plugins, which of course can be a lot of issues. It can cause a lot of damage, to your pipeline if there are updates that you do not do on time and all that. So the main aim of GitLab is to say, okay, you know what? Instead of installing plugins for this, plugin for that, we can just become that single platform, all right, where you put in your code, you're right, it's already a source control management system or a version control management system, all right, where you just put your code, and then within that same platform, right, you can run whatever pipeline that you want to run. So that's their own goal, and that's what they are trying to achieve, and that's where GitLab is going. So that's why you have GitLab, CI/CD, you have GitHub Actions, just basically saying, since you have your code in a repository, right, you don't need any third-party application to run your pipeline. You can just run your pipeline within the same platform, all right? So, and in DevOps, they call that concept, shifting things to the left. That's what they call that concept in DevOps. When you hear things like, oh, we're shifting things to the left, it just basically means we're moving things closer to our development environment. All right. Now with Jenkins, you have to install a server, you have to manage the server, you have a lot of overhead to deal with. But with GitLab, you have your source code, in the same place. You can run your pipeline in the same place. You can, your credentials and everything is within the same platform. You don't have to install any kind of plugins. And when you want to interact with AWS, you don't need any plugin. GitLab already has, a section that where you can put in your credentials, which we're going to see shortly. All right. So I just thought to give us that background. So if you look at what we have here, what we want to do today, basically what we're just, with this image, what we're just saying is that, from the code. Now in GitLab, in DevOps again, there's another concept that they say, from commit to production. All right, that's another concept in DevOps. They tell you, oh, okay, so how long is this going to take from the commit stage to production? So basically what they're saying is, how long is it going to take for us to work on this code, right? Commit it into the SCM and then push it into the production server, all right? So that's another terminology in DevOps. So when you hear things like, oh, commit to production, right? It's just basically a terminology in DevOps. So if you look at this image that we have, all right, we have a Python application that we want to push, all right? We want to test that Python application, maybe locally, and see if everything is all right. And then once the Python application has been tested, then we create a Docker image. Now with that Docker image is going to be pushed into a Docker repository. And then from that Docker repository, we're going to push it into our server. All right. And so GitLab is doing all of this for us. So everything is within, all right, our GitLab environment. Now, without further ado, let's go into the GitLab environment and let's see how these things work. Now, this is the application that we're working on. It's a Python application, just a simple Python application. Now, in the last session that we did on Thursday, all right, I showed us how we can push something to your GitHub or your GitLab repository from your system. So I will not be going over that again. Now, basically, this is a Python application that, our developers, they've done, they've worked on it, they've tested it, and they've told us, oh, okay, this thing is working fine. And then they have also tested it locally and everything seems to be okay. Now, if you look at what we have here, now, before you can build a CICD pipeline, For example, in Jenkins, we saw that we needed to have a Jenkins file, all right, within our code, right, in order for us to build our CI/CD pipeline. Now, for GitLab also, you need something similar, right, to your Jenkins file, because that is where you're going to provision all of the instructions, right, that will tell, your system that, oh, okay, this person wants to build a pipeline. Now, if you look at here, you have a CI/CD section around this place. Okay, we're going to be looking at all of these things shortly, but I just wanted to explain to us, what you need. Okay, now this is your application. Your application needs to be packaged, but of course, just like you have your Jenkins file where you define all of, let me see if I can get one here. All right, just like you have your Jenkins file where you have, where you define all of the necessary steps, all right, that your pipeline should follow, then the same thing also happens with your GitLab. Now, if you look at the Jenkins file, you have all those steps defined, the stages, okay, build this, push this to the image, deploy to an EC2 instance and all of that. And then you have a Groovy script where you have configured all of the logic, right? So if you look at it, this is the Groovy script where we have all the logic, configured for us and all of that. All right. So the same thing also applies to, GitLab CI/CD. So when you want to use GitLab CI/CD to run your pipeline, you also need what you call a .git-ci.yml file. Now we're going to be looking at a few differences between these two before we build our pipeline, so that for those who may not, be professional in this thing, maybe those who are just starting out, they can, easily understand, okay, why are we moving to GitLab? Why not Jenkins and all that? Now, for the sake of context, let me open this thing in a new tab, and then let's open up the GitLab also in another tab, and let's see the difference between these two. All right. Now, so this is, for example, this is another code that we've run, and then these are Jenkins file. Now look at the way the Jenkins file looks. Now the Jenkins file is written in what you can call a JavaScript object notation or a Groovy script. So basically, it's some form of a JavaScript object notation or Java. Basically, because you have curly braces, you have commas here and there, and all of that. Now let's look at let's have a look at what a GitLab CI/CD file. Let's look at what it looks like now. The difference between the two is that one is written, all right, in YAML, and then the other is written in what you can call a Groovy script, all right, which is a derivative of Java. Okay. Now, if you look at this one, I don't have the git.yaml file here, but of course I can create it. The idea is that you must have your CI/CD file within your source code, because by the time you want to run the CI/CD, your system is going to look within that file and find a particular file that has all the instruction that is necessary to run that application. All right. Now, for example, this is a Python application that we're trying to build, and then the Python application, basically, this is what it does. This is a README file. It's just an application that can show you, the performance of your system, memory performance, CPU performance, and all those kind of stuff. And so our developers, they've informed us that, this application, you need to install, certain files on your server in order for you to be able to run this application. So they've given us, maybe a kind of documentation, something that would enable us to run this file successfully. All right. So we're going to be following the documentation that our, developers have given us. Now, remember, you are not a developer, right? You're not a software developer, right? So it's not your job. It's not your duty to know, okay, what your own duty is to, follow whatever it is they're giving to you, go into your own environment, create those things, and then test out the application, build out the pipeline. And if everything works fine, all right, then you can tell your developer, oh, everything is fine. If there are errors, revert back to them to say, oh, based on what we just ran, these are the errors that this thing is showing us, and then they can go back and make that correction. So they've told us this is the application that we want to build. All right, you need to install this and this and that. So how do we now create, all right, a CI/CD file or a CI/CD pipeline in order for GitLab to do the same thing that Jenkins will have done for us? So the starting point here is this. Now we need to create a new file, right? We come here and then we click on new file. Now, for Jenkins, the name of the file is Jenkinsfile. That's the name. Now, for GitLab as well, the name of the file is also what you call a Git, or in other words, .gitlab, -ci.yml. That's the name of the file. So this is the name of the file. So if I click here now, this file must be written exactly like this. All right. Now, just like your Jenkins file, if you look at it, the Jenkins file is Jenkins file. The J is capital. If this J is in small or maybe lowercase, all right, Jenkins is not going to detect it. All right. So your Jenkins file is written exactly like this. And so if your Jenkins file is written exactly like this and you create a pipeline on Jenkins, the moment Jenkins detects this file in your source code, it runs, all right, whatever instruction that you have in that particular file. So the same thing also happens to GitLab CI/CD, right? So the name should be exactly written like this, .gitlab-ci.yml. That's how the name should be written, all right? That's how the name should be written. Now, the beautiful thing about GitLab CI/CD or GitHub Actions, all right, is that number one, it is written in YAML. Now, YAML is an easy to read kind of programming language, all right? It's easy to read, it's readable, very human readable compared to your Jenkins file, which has a lot of curly braces. Now with Jenkins file, you can make a lot of mistakes because you can forget to put, you can forget to open a bracket, and then you may forget a few things and all of that. But with YAML, it's simple. And that's why if you look at it critically, your Docker file is written in YAML because it's easy to understand, it's easy to read. Your Kubernetes files, all right, your deployment file in Kubernetes, your service file in Kubernetes, they're all written in YAML because YAML is simple, is easy to read, it's easy to understand. All right, we're going to see that as we go on in the course of this class. Now, so how do I tell my GitLab to run a pipeline for me? All right, how do I inform my GitLab to run a pipeline for me? Now, before we start, typing out some of the commands that will run the pipeline and all that. Now, your Jenkins is hosted on a server, right? For example, I have a Jenkins server that I just started right here. Okay, I have a Jenkins server right here. So my Jenkins is hosted on this server. Now, so somebody may wonder, so if you're using GitLab CI/CD, so how does GitLab, run those commands? How does GitLab, do all of the things that Jenkins is doing? Because, we are saying that, okay, we don't need to install any plugins and all of that. So how does GitLab actually run, okay, these commands and all of that? Now, it is pretty simple. Now, your GitLab uses what you call a runner. All right, a runner is just basically, a server that does all those jobs for you. All right, now, for those who will be joining the classes, we're going to delve into, what a runner is, how you can configure your own runners and all of that. But for the purpose of this example, we're going to be using the GitLab shared runner. Now, the GitLab shared runner is free. If you have a GitLab account, you can do it, you can use it and then use their shared runners and all of that, of course, but you will need to input your credit card details. All right. Of course, they're not going to debit you for anything, but you just want to be sure that, all right, you know exactly what you're doing. So it's going to ask for your credit card details in order for you to run, GitLab CI/CD, right? So I just thought to mention that. Now, your GitLab CI/CD uses what you call a runner, all right? And then, so if you input anything right here, it's going to use that runner to run that script for you. And the runner uses what uses Docker images. Right now, we're going to be interacting with Docker Hub because we're going to be pulling some images from there. But I just thought to explain to us that your GitLab uses what you call a runner. So a runner is just basically a server that does specific jobs or performs specific tasks for you. All right. Now, so that's what your GitLab uses. But your Jenkins, you can host your Jenkins on EC2 and then install all your plugins, and then your Jenkins does all that job for you. All right. But in this case, your GitLab uses a runner, so you can use the shared runner provided by GitLab, or in an advanced case, you can also bring your own runners, which means you have your own servers that you want to bring into GitLab to do your pipeline jobs for you. All right, so let's get started. So how do we run a pipeline, all right, in GitLab? Now, the first thing is this: if you want to run any test, now let's look at Jenkins again. Oh, okay, Mr. Eric, right? Please, you can unmute yourself and ask your question, Mr. Eric.
Yes. So, please, I want to ask a question about the CICD tool, because you are saying that Jenkins depends on a lot of plugins. Yes. And the best CICD tool now to use is what? GitLab. So I want to ask, in the real working environment, which one do the companies use? Is it Jenkins or GitLab CICD?
All right, that's a very good question. Now, organizations differs, right? So some organizations still use Jenkins, and some of them have moved, all right, to GitLab CI/CD. Now, let me give you an example. I attended an interview 2 weeks ago, all right, and it was a DevOps interview, because sometimes I take some of those interviews just to understand, what organizations are doing, what are they using, and all that. Now, I didn't know that the company were using GitLab CI/CD. I just mentioned it to the man. I showed him my GitLab account, showed him a few pipelines that I've run and all that, and then he told me that in fact I actually got ahead of him and all that, that they moved away from Jenkins to CI/CD, to GitLab CI/CD. Now, organizations are transitioning, all right, from Jenkins to GitHub Actions or GitLab CI/CD. And the reason, like I mentioned, is because Jenkins involves a lot of plugins, all right? And then you don't want, maybe because of an update in Jenkins and all that, and then that affects your production environment and production system and stuff like that, all right? You don't want something like that. So organizations in a real-world environment, some of them are still using Jenkins, all right? And some of them are already transitioning to GitLab CI/CD. Some are using GitHub Actions. Now, the idea is this, like I mentioned earlier, is the concept of shifting things to the left, right? So basically, if I have my source code, if I have all my code in GitLab, and GitLab can run my pipeline for me, why do I need to install another server, incur another cost, all right, to run my pipeline? I don't know if you understand that logic. So that's why organizations are moving from Jenkins to GitLab CI/CD or GitHub Action. So in the real world environment, you can have an organization, you can go to an interview and they tell you, oh, we're using Jenkins, and then a few months down the line, they're transitioning. You can attend an interview and they tell you, oh, we're using GitLab CI/CD or we're using GitHub Actions, all right? And that is why in the course of the class that we are starting, apart from introducing people to Jenkins, the syntax, how Jenkins work and all that, we are also doing the GitLab CI/CD so that you can have an idea of the two, so that by the time you go for an interview and they ask you about Jenkins, you know what to say, you know how it works, you've interacted with it, and then if the interviewer also asks you about GitLab CI/CD, you know the right response to give to them. All right, so that's why we are combining the two in the course of our training. So we're not focusing only on Jenkins, we're also doing GitLab CI/CD, so that by the time you have the knowledge of the two, whichever interview you attend, whichever one the organization that you want to join uses, you already have the knowledge, you can interact with any of them, all right, regardless. Okay, so in a real world environment, yes, they can use Jenkins, they can use GitLab CI/CD, it depends on the organization. I don't know if your question has been answered.
Yes, it's been answered. And please, I have a follow-up question. So what about, in my, let me say that somebody who did Jenkins or who learned about Jenkins, and the person doesn't know about GitLab CI/CD, and the person goes for an interview in an organization that they don't use Jenkins CI/CD, they use GitLab. What happens to such a person?
Well, now one thing you must know is this. Now, in an interview, for most of the interviews, maybe they are looking for one candidate or two candidates, and that's why. Now, let me answer this question like this. Now, there was a webinar that I attended yesterday, and a lady was asking a very honest question. Of course, whatever she was asking was very valid. And what was the question? Now, she was asking that, she has done DevOps training and all of that. The webinar was actually on Kubernetes and stuff like that. So she was asking that, okay, she has done DevOps, and then, she sees that, there's a lot of jobs in DevOps, a lot of people are trying to move in and all of that. So it's difficult to get a job and all that. Now, to answer your question, I said that to say this, that is why if you are looking for a job, if you're looking for, maybe you want to switch careers, you want to move on to newer roles and all that, you must ensure, right, that whatever skill that is required in that field, you must ensure that you have it right in your arsenal, because you're not the only person applying for the job. Now, if you say you only know Jenkins and you don't know GitLab CI/CD, all right, and the organization is looking for somebody that knows that. Now, don't forget, the interview that you're attending, you're not the only person attending. So perhaps there are 5 people, 6 people that are attending, and chances are that one of those people would be familiar with GitLab CI/CD. And so if the organization finds somebody who has something close to what they are looking for, chances are that they may likely drop the person who knows only Jenkins. All right. And that is why if you look at some of these job applications, they have what you call maybe, required skill, and then they have what you call, maybe nice to have skills and all of that, right? Now, if you have the required skills, and then somebody also who attends the interview has the required skill, and that person also has some of the nice to have skills, right? Chances are excellent that they will go with the person who has, all right, then some of the nice to have skills, right? And that is why, like I said, in the course of the training, we are not focusing only on Jenkins, because we understand the trend, what is going on right now. I can tell you that in the next 2-3 years, right, Jenkins is not going to be as popular as it is today. All right, what you'll be hearing now is GitLab CI/CD, GitHub Actions, and stuff like that. And so that's why we are taking the extra step to say, okay, Jenkins, the knowledge is good, have it, know it. But in addition to that, right, understand GitLab CI/CD as well. So that, like I said earlier, if you attend an interview and they are saying, oh, GitLab CI/CD is what we're using, you have it. You can answer questions on it. If they ask you any questions about it, you can answer them correctly. And then if it is Jenkins they are using, you can also perform very well. So that at the end of the day, if there are 3 people, 4 people that attend the interview and they only want to pick one person, you are better positioned to get the job than somebody who just has one of the numerous skills that they are looking for. All right. So in order for you to be position yourself very well, that's why you need to have, understanding of all these extra skills, because there's a lot of openings out there, but at the same time too, there are a lot of people that are also looking, all right, to apply to that same opening. So that's why you need to understand all of these necessary tools in order to position yourself better for the job that you're looking for. I don't know if I've answered that question.
Yes. Thank you very much, sir.
All right. So let us go ahead with a pipeline. All right. So now, if you look at your Jenkins pipeline is built, right? There are stages in your Jenkins pipeline, right? It moves from one stage to another, and stuff like that. Now, in your GitLab CI/CD as well, it also follows the same pattern, okay? It follows the same pattern. So you have stages that you have to provision within your GitLab steps or your GitLab CI/CD YAML file as well. All right, so let's look at how we can do all of those stages. Now, like I said earlier, our engineers, our software developers have told us, okay, this Python application, you need to install some dependencies in order for this Python application to work as expected. So the first thing we want to do now is to install some of those dependencies so that our application can work and can perform as expected. All right. Now, one thing you must also note is that by default, the GitLab runners that I mentioned earlier, they run what you call, a Ruby image. All right. Because your GitLab runners, they also run, Docker containers, right? They use Docker to also run all of the workloads that you want to run. So let's go to Docker Hub, because Docker Hub is where you pull, is a public repository where you pull images from. So if any image that you need, whether for Python, for Apache, and all of that, you get it from your Docker Hub repository. All right. Now, like I mentioned, the GitLab runners, all right, they use Ruby as their own base image. All right. And what we are trying to build, it's a Python application and not a Ruby application. So we need a way to override that. All right. We need a way to override, that, so that Because if it runs on Ruby, it's not going to work because what we're trying to do is a Python application. So we need a Python image to run a Python application. All right. If you're running a Ruby image, of course, you need a Ruby application, you need a Ruby image. If you're running a Java application, for example, you need a Java image to do that. All right. So in order for us to be able to tell our runners that, okay, see, this application that I'm running needs a Python image, then we need to provision that, all right away. So the first thing we want to do is to type in what you call, maybe you want to run a test. As that's technically what you want to do. You want to test the application before you package it into a Docker image and then push it into an EC2 instance. All right, that's what you want to do. You want to, first of all, test that application. And then if the application is tested and is successful, then you can now move on to the stage of packaging it into a Docker image and then pushing it into a repository. And then from there, you can then run it on your, all right, your EC2 instance. So the first thing you want to do is to run a test. And don't forget, we are running a Python application. So the first thing we want to run a test. And then what is this first stage? All right, the first stage is what? Is the test stage. The same thing that we have in Jenkins, right? Where we define, all right, build stage, test stage, you know, all those things that we have here. Then before you go over to your script and all of that. So it's the same concept as well. It's just that the language for GitLab is YAML, the language for Jenkins is Groovy script, but it still follows the same kind of logic. All right, so now the first stage is what we want to run a test. And so for this test, what is the image that we are using for this test? Like I mentioned, your Jenkins CICD uses a Ruby image by default, all right? Sorry, your GitLab runners uses a Ruby image by default. So we need a way to override that. Now, overriding that does not now mean that you can use any Python image that you have, right? Because if you go to Docker Hub here, for example, and you type in Python, there are a lot of Python images that would pop up on your screen, all right? A lot of Python images would pop up. Now, if you look at it here, this is the official image for Python, updated 2 days ago, over 1 billion downloads and all of that. So if I click on it, I have a lot of Python images here, right? There's 3.12, there's 3.this, a lot of all these images. Now, like I mentioned, you are not a software developer, so the development team or the software developers, they must have informed you that, oh, this application we developed using Python 3.so and so your own job is to go to the Docker Hub repository and look for the specific Python that they have used, all right, to build that image, okay, so that you won't run into any errors. Because, for example, if they built the Python application, let's say with Python 3.12, and then you are trying to build or run that image with Python 3.8, for example, definitely there's going to be a lot of errors, all right? There's going to be a lot of issues. So they have told you, oh, this image is built using Python 3.9, for example, all right? So your own job as the DevOps engineer, you go to the Docker Repo and look for Python 3.9 image. Now, Python 3.9 also has different variants, right? So you need to also know what specific Python 3.9 have you guys tested, have you guys used that you think will work for this purpose. Now, in our own case, we're using the Python 3.9 Slim Buster, all right? That is what we are using. All right, because based on the information that we got from our development guys, they've told us already that they used, okay, Python 3.9 Slim Buster. All right, and so it will not make sense for us to use another image, all right, to run that same application. All right, Mr. Della, right, please go ahead and ask a question. You've been unmuted. You can ask a question, please.
Thank you so much. I believe there's a place in the source code that you can see which version of Python is required for you to run the application, right? And if you could share with us where to locate that, please. Thank you.
All right, now that's a good question. Now, I said something earlier. I said, let me manage this. I said something earlier, and what I said was, let me commit this. Let me just commit these changes. Now, let's go to the repository. Now, I said something earlier. I said, as as a DevOps engineer, you're working with the development team, all right? Now, this is the code that we're trying to run. So if you click on this test, for example, let's see, I think something should be a test, okay? Now, if you click on this code, let's go to source, all right? So this is the, all right, this is the source. They run the pipe, this is the requirements, all right? So the requirement basically details some of the things that has to be installed in order for this application to work correctly, all right? So which means you need to install all these Flask, Python utility and all of that for the application to run correctly, all right? These are some of the things that the pipeline is going to run for us, all right? If I click on the run.py, if you look at the run.py here, it doesn't tell you what version of Python this application has used, all right? And if you go again, if you look at the source and you go to apps, all right, if you see all of these are just things that the developers have put together in order to run the application. So if I go to int.py, for example, it doesn't show me any version, right? It doesn't give me any int. If I click on this, it doesn't give me any int as to whether it uses Python 3.10 or Python 3.9. All right. The idea is this, all right? Within the application of the Python application itself, you may not know whatever version is written. And that is why I said you are working with the developers. They are the one that came up with the program, right? And so they have a documentation that they will give to you to tell you that to say, this application was developed using Python 3.9 or Python 3.10. Your own duty as the DevOps engineer is to, all right, set up an infrastructure, all right, that would be able to run that application successfully based on the information that you have gotten from your development team, all right? Because if you look at the code that we have here, it's just basically, the Python code, right? What the Python application would do for us. It doesn't show us, all right, whether it is written. If you go to test, for example, test API. Okay, so if you look at it here, we don't have anything that tells us, oh, this is written in Python 3.9 or 3.10. And so that's why I said that that information is going to come from the development team. If I click on these ones, it doesn't give me any details as to what version of Python, all right, this application, all right, is written, all right, in. Okay, so deploy again, doesn't give us anything. Kubernetes, it doesn't give us anything right here. All right, so like I said, whatever version, all right, of Python or whatever version, now it doesn't even apply to Python alone. It can be anything. It can be a Java application. It can be anything. It can be a Node application, a Node.js application, or anything. It can be anything, right? But like I said, the most important thing is that you are working with the development team, so they are the one that will provide you with that information. I don't know if I have answered your question.
Thank you very much.
All right. Okay. Somebody else is raising. Okay, please go ahead. You've been unmuted. You can go ahead and ask your question.
Sir, I have a question.
Please go ahead.
So how can we know that which version programming is there? It means
All right.
if Python is there or anything programming code is there, and how we are going to know which version programming is there in that?
All right. It still goes back to the same, response that I gave, right? That, for example, if you are running this application, for example, now if you look at this one that we have here, for example, this is a Jenkinsfile. This is a Node.js application. All right. So, for example, this Node.js application now, I cannot be using Python to run this. All right. That would be, that would not make any sense, because every programming language, they have their extension, they have their package managers, all right, that works with them. Okay, so if you see a Python application, all right, you already know. So when you're seeing anything that ends with .py and all of that, you already know. And that is why I said, as a DevOps engineer, you are not working on your own. You are not the one developing the application, all right? You are working with a development team. Your own job majorly is that you set up an infrastructure that can ensure that, the code moves from the commit stage, all right, to the production stage, all right? That is basically your own job, All right. So if it is a node application, the developers, it is their duty to inform you that, oh, we're building an application, we're developing, an application in Java, we're developing an application with .NET and all of that. So your own job is to build an infrastructure that can ensure that whatever application they are running, whether Python, whether Node.js, whether .NET, whether Java, that infrastructure is able to run that application. That is your own job. All right. So is that okay? Are you okay with that response?
Oh, I got it, sir. Got it.
All right. So let's move ahead. All right. Now, so let's go back to our page. Now you can see that because I didn't type that thing correctly, now GitLab already sensed, all right, because I have a gitlab.ci.yml file. So you already sense that, oh, okay, that's a pipeline file. So automatically it tried to run, all right, that pipeline, and it failed because we didn't complete that step, all right? That's why you can see this arrow here that the pipeline failed. So let's go back to it and then let's make the necessary correction. All right, so here I'm going to specify the image that this application should use to run. And like I said, based on the information that we got from our developers, they have informed us, all right, that we're going to be using a Python 3.9 Docker image, all right, in order to run this application. So what I need to do is just to go to Python here, and then all I need to do is just to copy this. And all right, I copy that. Okay. I can go back here and then paste that right here. Okay, that's not correct. So I need to put in Python. All right, Python. I think there's a column there. All right, so Python column. All right, and then it's showing us an error. Okay, so let's correct these things. There should be a space here, and there should be a space here as well. All right, your YAML file is also very sensitive. You can see that it was the space that was causing a lot of issues there. All right, so the image, we're giving it the image to run. Now, this that we have done here now, all right, will not give us what we want, because don't forget, there are a few dependencies that we need to install. Now, if you look at, let's open this in a new tab. Let me show something. Now, there are a few things that, we need to install in that container, all right? So this Python image that we want to run, there are a few things that we want to run inside of that container, right? So that our applications can run correctly. Now, if you look at this file, for example, there's this make file here. If you click on it, all right, now this make file is what we need to first of all install, which basically it's what would do what you call a compilation. All right, the make file here is just, now all these things that I'm saying, I am assuming that, okay, this is the information that my developers have given to me, because all these things here, I am not a developer. I don't even know what all of these things is, right? So I'm assuming that, okay, my developer, they've given this to me. They've given me a brief concerning these things and what I need to do in order to test this application. So this is the file that I need in order for me to test the application. So the only thing you can see here is what is just Python 3. You can see Python 3 here. And then once you run this script, for example, it's going to install, all right, pip is going to get installed. And then there's what you call the requirement.txt, which is in the source directory that is going to run. All right, now all this information, again, like I said, these are information that your developers will have given you a brief of, because you are not the one that will write all this, whatever code this is. You're not the one that will write it. They are the one that will write it, and then they will give you proper briefing that will ensure that this thing runs successfully. Okay, all right. So now we want to, all right, run this particular make file. And in order for us to run this make file, we need to have that make, available on our system, right? Now, there's no big deal about these things now, right? if you are installing anything on our system, I'm sure some of us have installed certain things before. For example, if you're a Windows user, for example, there are certain applications you want to run, and then it will tell you, oh, this so file is missing. You have to install it. For example, if you want to install a Docker, a Docker virtual desktop or something on your system on Windows, there are certain Windows dependencies or C++ libraries that you need to have installed first on your Windows system in order for you to run that application. So it's not like, okay, these things, how do they get it? How is it possible? No. It's just dependencies, right, that you need to have in order for your application to run successfully. Okay? So now, in order for us to run this pipeline successfully, we need to have those dependencies on our system in order for our Python image to compile successfully and to run this, makefile, right? This makefile is just to test the Python application to ensure that the Python application is going to run, all right? And that's why we need to, compile this makefile. So how do we go about that? So we have our image. Now, in Jenkins, again, let's go back to our beloved Jenkins. Where are you? Where is this? Okay. Let's look at our Jenkins script again. Now, in Jenkins, you have a section that is called script, right? Which is where you now define, what script you want to run, what is it that you want Jenkins to run for you at that particular stage, all right? Now, in GitLab CICD as well, you have where you have to define the script also. Now, don't forget, before we can define the script, I said earlier, there are a few things that must be installed on our system in order for that script to run correctly. So in GitLab CI/CD, they call it before script. All right? They call it what? Before script. So which means you have to run this one before you run the main script. All right? So they call it what? Before script. Now, so the before script is just something that gives us like, a buffer to say, okay, before the main script is run, perhaps you have some dependencies you want to install, perhaps you have some application that you want to install before the main script, then you can use that command before script, and then you put all those commands there that will run before the main script. So what are the things we want to do? First, we want to do some updates. This is the Linux command. So we want to do some updates, apt-get updates, all right? And then after the update has been done, we also want to, install now the dependency that we need in order for us to compile our Python application. So we're updating the system, and then after the update has been done, we also want to install, the make file or the make, package that we need to run or to compile the Python application that we have. So once you have this, you can now run your script. So you go back a bit and then you put in script, you can use tab to complete this. So tab to complete that. And then right there, you now put in your column, okay? And then you press enter. The indentation is done for you automatically. And so what you want to do is just to test, your Python application. So that's what you want to do basically. Now you can see that after we have typed in all the correct things, our pipeline tells us that the syntax is now correct. And so hopefully if we commit this, the pipeline should run automatically by itself. All right, so now we've done this. So we're running the test. So what test are we running? The test is built on a Python image. And so before the main script runs, like I told us, we're trying to compile, we're trying to run this particular file. And so for you to compile this make file based on the information that our developer gave us, we need to have the make package installed on our system in order to compile this application or to test our application and to be sure that the application will run correctly. And then we can then package it into a Docker image and then send it to our EC2 instance once we're sure that all those things would work. All right, now, so the next thing I want to do is to commit this. Now, if you look at Jenkins again, when you commit a change in Jenkins, or when you commit a change in your GitLab, for example, you go back to your Jenkins, pipeline, you run the build again, Jenkins will go to your GitLab, check for any new changes, run those scripts again. But here, we don't need to go anywhere. Everything is within, this particular place. Okay, so now we can commit our changes. We can commit our changes right here. And then if I click on commit, this pipeline is going to run. You can see that the pipeline is running. All right, so if I click on this, for example, all right, I can click on the pipeline here, the ID of the pipeline, and then it tells me that one job is running right now. All right, so if I click on the running job again, it will take me to write a page. Now, this is just the same thing as your console output in Jenkins, right? For those of us who joined the last session, so we saw the console outputs, you know, all those stuffs right there. So this is just an example of your console output in Jenkins, so you can begin to connect them or relate them with one another. All right, so now obviously our application ran successfully. The test, so you can see here, the first step is using a Docker image, and then it tells you, the first one here tells that it's running with GitLab runner. All right, this is a GitLab runner. So basically, this is just an ID of a server somewhere that is owned by GitLab. All right, so we're using their own shared runner. And so, all right, and then we're trying to use the Docker image. So because we are overwriting the default image, like I told us, the default image is a Ruby image, but we're overwriting that. So it's running a Python image, and then the Python image has been pulled. You can see that it's saying pulling, all right, pulling image, all right, from Docker up. So the image was pulled from Docker up, and then it prepared the environment, and then, all right, it goes into our repository. From here, the same thing that Jenkins would do, going into the repository, all right, checking out the repository, blah, 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 and then, running whatever it is that we ask it to run. So you can see this is the command the script that we ran, make test. All right, the before script, let's see the before script. All right, now this is the before script, all right, in action. Executing step script, change, all right, stage of the job script. So this is the before script. You can see that the before script here ran successfully. So he updated our system, and then he installed the make, was installed for us automatically from here. And then after the make has been installed, which is the before script, then the main script was now executed. So you can see the main script right here. All right, the main script was executed. So all those requirements that we saw earlier, the Flask requirement, all these things were now installed on our system, right? You can see that all the requirements got installed. So after the requirements have been installed again, then, all right, it then successfully tested the application. So it was using Python 3.961. So you can see that all the tests that we ran, everything passed, and then it told us that the job succeeded. All right. All right, very good question, Mr. Okereke. Now let me show us that. Now, this person is asking, where is the makefile located, and how does GitLab retrieve the location, all right, in order to correctly install? Very good question. Very good question. Now, that will take us back again to, let's go back to our repository. Now, let me explain it with the Jenkins that we did last time. For example, now, based on the question you asked her that, okay, so how does GitLab know that there's one makefile somewhere and all that? Now, that's a very good question. Now, in Jenkins, you also have your Jenkins file. So one will be wondering, so how does Jenkins understand, all right, how to pull my image and all that? Now, we are dealing with a source code management system, right? So everything you need for your application to run is within that, SCM environment, right? Everything is there. Now, if you look at this Jenkins file that you have here, basically we have defined, right, all of those steps, okay, within Jenkins, all the steps that we want it to run. Now, within those steps, all right, that is where you're going to specify what is it that you want your Jenkins to do, for example. Now, if you look at the Groovy script that we defined here, the first thing we want Jenkins to do is to build an image, all right? So the question now is, so how does Jenkins build an image for me? Where does Jenkins find the file, all right, that can ensure that the image is built? what do? You basically type out the commands for building that image. So Jenkins look at that command, and then it looks within your SCM and to find, all right, based on the command you're specified, it looks within your SCM to now find something that correlates, all right, to that command that you have entered. Now, if you look at this command right here, this is Docker build, all right? So we are building an image from a Docker file, and then we have a dot here. So the dot signifies that, okay, there's a Docker file in this present directory, all right? There's a Docker file in the present directory. So Jenkins looks at this code and say, okay, based on this command that this person has done, definitely what this person wants me to do is something that is present, all right, within this my SM. So Jenkins goes there to look for it based on the command, all right? So the command that you put in is what actually gives your SCM some kind of knowledge or some kind of information as to what you are trying to do. All right. Now, if we go back to the image that we just ran, now don't forget we have a make file here, all right, within this SCM. Now, our GitLab CI file is also within that same, all right, SCM is in the same root directory. Now, the command that we initiated, if you look at the GitLab CI/CD, the command that we initiated basically, sorry, why is it not showing? All right, now the command that we executed basically, it says we want to run what? We want to run a script, and so we want to run a make file. So if you type in make, now make is a package, and we have, all right, a file within our repository that has been written using the same make package. All right, so automatically what you're telling Git CI/CD is to say what? This is the script that I want to run. So what will Git do? It's going to go back into your SCM to look for something that corresponds to this. All right, the same way your Jenkins is going to look for something that corresponds, because this dot means a Docker file, right? So your Jenkins is going to look for something that corresponds, all right, to a Docker file, and if it finds it, it's going to run that application. All right, so the same thing also happens with this. So your GitLab CI/CD is going to look within that source code repository, all the codes, all the folders, and all the files that you have there. So if it finds something that corresponds to a make file, right, it's going to run that script automatically. I don't know if that answers your question. If that answers your question, let us know. Does that answer your question? All right, so we can go on. All right, so we have done the first step. Okay, the first step has been completed. Now, there are other steps because where we are going is still far. All right, what we have just done basically is just, we have tested. Now, it's just the stage that we are in. We still need to build this thing into, a Docker image, right? We need to build it into a Docker image and then push it into a repository and then finally to our EC2 instance, right? So we have done the first stage. So let's look at how we can now do, all right, the second step, all right? So let's look at how we can achieve that. So let's go back to our GitLab and let's see what we can do. Now, in order for you to be able to push, all right, your application into the Docker hub, or package it into you want to package into a Docker image and then push it into your Docker repository, all right, you need to log in into, for example, I'm using a Docker hub here. Of course, you can use ECR, all right? If, for example, if you're working with an organization that uses AWS, of course, you're going to be using ECR, right? You're not going to be using a Docker Hub repository, but I've just chosen to use Docker Hub because it's easier to just work with, because with your ECR, you need to configure, certain stuff, your access key, secret key, and all those kind of things. You need to provision all of that. So the first thing you want to do is that you want to authenticate, all right, with Docker Hub, right? Of course, for any repository that you choose to use, the first step is to what? Is to authenticate. So which means GitLab needs a way to be able to communicate with your Docker, all right, your Docker Hub repository. Now, don't forget, when we did Jenkins, we also did the same thing. If you look at the Jenkins file we had here, we had to pass in some, some credentials parameters in order for Jenkins to also authenticate, with our Docker Hub repository. So the same thing that we did with Jenkins, provisioning credentials in Jenkins and then using that to now link up our Docker Hub is also the same thing that we are also going to be doing with our GitLab CI/CD. But then GitLab has a way to manage this, because everything is provisioned within your GitLab environment. Everything is provisioned within your GitLab environment. So now, because for example, if you're working with Jenkins, for example, you need to install the credentials plugin, and then before you can start, provisioning credentials. But with Jenkins, everything is within. You don't need any additional plugin to do that. All right. So let's go back to our GitLab, and then let's see how we can, provide the credentials that we need in order for our GitLab to connect to our Docker Hub repository. Now, how do you get that? Now, if you go to settings from here, you are going to see GitLab. We're going to see CI/CD right here. Okay. Now there's the CI/CD here, but that one is just where you can view your pipelines and all of that. So if I click on this one that I have here, what I can do with that is just to view, the pipeline that I've run, the one that failed, the one that succeeded, and all that. But if I want to pass in, credentials, if I want to do some authentication with an external, service, I need to go to settings, and then I'll go to CI/CD from here. All right. So if you scroll down, you have what you call variables, right? You have variables right here. So now under these variables, this is where we're going to be provisioning our credentials, for GitLab CI/CD. Okay. So if you click on expand, it tells me I don't have any variables yet. So I can click here to do what? To add variables. So click on add variables. So what type of variables am I adding? All right, what types of variable am I hiding? Of course, it's a variable, it's not a file. All right, what's the environment? I don't have anyone here. So now the key can be the username, and then you can have the value as your password. All right, so you need to provide all of that details. So for example, you can create what you call a protected variable. You can also mask the variable, so that when you mask the variable, the purpose of masking your variable is so that, within your pipeline job, that console output that you see, if you mask your variable, all those details is not going to, will not appear, and that's the purpose of masking your variable, all right? So let us create, so the first thing you want to do here is to put in your, let's say Docker Hub, or we can say, so what you want to do now is to want to provide the username and the password for your Docker Hub, right? So what you want to do is I'm looking for a simple variable to use. So we can say username, all right? So let's say username for that. So what's the username for my Docker Hub repository? So I'll put in the username right here. Okay, so that's the username. So I want to protect it, I want to mask it, I can do all of that. So let's add this variable. So that's the first variable that I've added. So this is the key. So I'm going to be referencing this key within my GitLab CI/CD, file. Shortly. The second one you want to add is, you want to add in your password. All right. So let's provide that. I'm going to user pass. Okay. So let me put in my password, and then I'll share my screen later with us. So let me just quickly type in my password. All right. So password. Okay. All right. So that has been added. So let me share my screen with us again. So I've added my username and I've added my password, right? I've added my username and I have added my password. So what we want to do now is to go over to our file, okay? We need to go over to our file and then we want to reference the username and the password that we have just created so that our GitLab CI/CD can push, all right, can package the application into an image and then push it into a Docker or repository, all right? So let's go back to our item here. So let's edit, okay? We can edit in Pipeline Editor, that's okay. All right, so now the first thing is that we have run the test. So the next thing now is that we want to build the image, all right? That's the next thing that we want to do. We want to build the Docker image. So it's still the same thing. So we need to put in build image here. All right, so you put in that, you put your column, and then you press enter. Okay, so that will do the indentation for you. So what's the image? Now, what are we trying to do? We're trying to build a Docker image. All right, so if you're trying to build a Docker image, so that means in Jenkins, right, your Jenkins has, let me quickly show something, all right? Let me quickly show something just to explain this concept so that we don't get lost. Now, follow me here to my console. Now, I have this Jenkins server right here. Let me log in into the Jenkins server to explain, what I'm about to do in the GitLab so that we can understand these things clearly, all right? So that it doesn't look like some, abracadabra and stuff like that. Now, in your Jenkins server, now don't forget your Jenkins is installed on an EC2 instance, just like we have here. But then Jenkins can build a Docker image. So the question is, so how does your Jenkins build a Docker image, right? How does it, because before you can build a Docker image, it means that you must have Docker installed, all right, on that system. I don't know if I'm right on that. You need to have Docker installed on the system because Docker build is part of Docker commands, right? So if you don't have Docker installed on the system, so how can you run Docker build? All right, how can you run, Docker tag and all this kind of stuff? So which means you need to find a way to make sure that Docker is also available on the system that is running your CI/CD pipeline. So now let's log into our Jenkins. Let me just show us a few stuff so that we don't, I don't want us to just assume things. So let's, look at these things critically so that if there's anything that we're missing, we can ask questions and then we can understand the way this thing works. You can see my screens, right? My terminal is up here. Okay, I want to log in into, all right, so let me change my directory because I need to get my, my key pair is in that folder. So I need to SSH into my Jenkins right now. So my key pair is in this directory. So that's my key pair. The username for my Jenkins server is admin because it's hosted on a Debian server that's the IP address of my Jenkins server. So press enter. I'll do yes. All right, so I am in my Jenkins server right away. All right, now on this Jenkins server, if I want to, because my Jenkins is hosted, right, on, using a Docker image, right? I didn't install Jenkins directly on this server. So I used a Docker image instead. So if I do Docker PS, for example, I should get an error, all right? Because I cannot run that, directly like this. So I need to do some kind of connections in order for me to be able to interact with my Docker. So the first thing I want to do is to elevate my privilege. So it's super user privilege, all right? So Docker SU. So right here, if I do Docker PS, I won't see anything. If I do Docker PS-A, I will see a few containers that I have running. Of course, these ones are not running anyway. They are containers that I have stopped. Now, my Jenkins is right here. This is my Jenkins container image. All right. Now, in order for my Jenkins server, because now this server that you see here has Docker installed. Okay, and my Jenkins is also running as a Docker container. All right. Now, in order to make the same Docker that I have on this system, in order to make it available for Jenkins, all right, because it won't make sense for me to start installing Docker into the Docker container again. I don't know if you understand what I'm saying. All right. So we already have Docker on this, my server running. And at the same time, I want to make available, right, the Docker runtime. Okay. The Docker runtime that I have on this server, I want to make it available within Jenkins. So that if I do Docker build on Jenkins, Jenkins can build Docker images for me and do all the necessary stuff. All right, so how do I enable it? Now, the first thing I want to do is to, all right, I want to copy this. I want to start this container. All right, so that will start my Jenkins server for me. So basically, I'll just do Docker start. All right, so that will start a container for me. Now, in order for me to make Jenkins available on this container, right? This container is what is hosting my Jenkins. And in order for me to make, Docker available for that container, so that that Jenkins that is on that container can run Docker commands, I need to do what you call, I need to log in into that container. Now, you cannot log in into a Docker image. Let's get that. You cannot log in into a Docker image, and you cannot log in into a container that has been stopped. All right, you can only log in into a container that is running. Okay, you can log in into a container. And how do you log into a container that is running? You have to execute, bash command. So if I want to log in into this container, it's already running. I can put bash in front of it here. And then I go back a bit. I put in, exec. So I want to execute, some kind of shell command. And then I have my -it. IT there means, I want it to be iterative. I want to be able to interact with, my container. All right. And then I want to log in as a root user. All right. So I put in -u to say, and then 0. Now that 0 means, all right, I'm going in as a root user. That's what the 0 there means. Okay. So if I press enter, now I am in my container. All right. Now, if I do Docker versions, for example, all right, you can see that the Docker is available onto me within this container. But then I still need to do some kind of permissions in order for my container to run Docker commands, all right, in order for Jenkins to be able to run Docker commands. So what do I do? What I need to do is to do chmod, which is, you're right, I want to change the mode. I want to give it some kind of permissions, and then I do var run, and then the Docker runtime, right? So that's the Docker socket. So I do that. So once this is done, right, then my Jenkins can now begin to run Docker images. All right, it can begin to build rather Docker images. Okay, so how does this now relate to this GitLab CI/CD that we are talking about? So let's go back there and let's see how it relates. Now, we want to also build, right, Docker images. So in order for that to happen, we will need to install a Docker image. Now, the same way we pulled a Python image, all right, in order to test our application, we also need to pull a Docker image so that our GitLab, all right, can build Docker images for us. Now, in GitLab, they call it DIND, which is Docker in Docker. All right, Docker in Docker. So you are running a Docker within a Docker image. All right, so you have a Docker image that is running, and then within that same Docker image, you are also running, Docker runtime there. And the purpose of that is because you want to build Docker images. So the image, how do we get the image to do this? Now we go back again to our Docker hub, and then we look for Docker. We just type in Docker right there. So it will show us the Docker image. Let's see, do we have any Docker image? Do we have any Docker image? We need to look for, okay, yeah. So there we go. So this is what we're looking for. So you can see what they call it. They call it what? Docker in Docker. All right, that's what it's called. It is called what? Docker in Docker. So basically, what is just the concept is just that I want to run a Docker. I want to build Docker images, right? I don't want to install another server to do that for me. So within that Docker image, the moment that Docker image turns into a container, I want to be able to use that same container to build Docker images, right? That's just the concept. all right? It's not something, so, you know, I hope you get what I'm saying. So I have a Docker image. The Docker image is running as a container now. And within that same container, I want to build Docker images, all right? So that's what this Docker in Docker thing it's all about. So if I click on it, I will go with a specific version, right? So there are a lot of versions right here. Okay, there are a lot of versions right here. Now, the fact that something is the latest. Now, let me just say this: the fact that an application has a latest version does not mean that that latest version is going to work correctly for your own environment, and that is why, for organizations, you will see that organizations they don't do upgrades regularly, right? Especially organizations that are working within, maybe a regulated kind of sector, like maybe banking, for example. You won't see banks, upgrade their systems regularly. No, they do it at intervals because there are several applications that you're running, and then some of those applications needs to be very stable, all right, in order for you to be able to guarantee, excellent service delivery and all that to your customers, right? So the fact that, oh, this thing is the latest version, we need to, no. You don't have to run latest versions of things every time. You can go with previous versions as long as that previous version is stable and it has been tested and there are no vulnerabilities. You can go with it anytime and any day. So the image I'm looking for is Docker 20 or something. Let me see, can I find it here? It's not available here, but I used it before. So if I want to look at it, I can go to tags here. If I go to tags, I can now, all right, I can filter. Okay, so I'm looking for 20 point something. All right, so now this is the 20 that I'm looking for. So yeah, Docker dind, yeah, that's not what I'm looking for because I need to first install a Docker image before I can use the dind. All right, okay, so this is one. This is one Docker image. So this is version 20.1024. Now you can run that as well, that's okay. But let's look for, I think we're looking for 20.10. All right. So let me not waste time on this. Let me just type in what we're looking for. Let me go there. Where is it? So the version that I need is just Docker. All right. I'll type in Docker colon. The version is 20.10.16. That's the version I'm looking for. All right. And then now within this image, there's a service that I want to run within this image. All right. So I need to put in that. So the service or services, right, is okay. All right. So the service is what you call the Docker in Docker. So that's the service that I want to run, all right, with this Docker, because the purpose of this is that I want to build an image and I need a Docker container to do that for me within GitLab. All right. GitLab does not have what it takes to build, all right, an image. So I need a Docker image. And then once that Docker image has been started up as a container, all right, that Docker image will now take, all right, my Docker file and then package it into a Docker image for me. So I'm looking for 20, right, 10.16. All right, and then I'll put in dind. If you look at this place again, you will see that we have some dinds right here. So this is basically what we've just done. All right, Docker in Docker. That's what we're running. So you get an image like this, all right, and within this image, you have a service called Docker in Docker. So if you look at it, this is 2.10 image, and then you have another 2.10-dind. So this is the Docker image, and then this is the Docker in Docker service that will do the Docker build for you. All right. So we've done that. And by default as well, your Docker also, you have to specify what you call variables. And the variable is just basically your Docker needs some kind of certificates to run because the way Docker images work, when you want to build a Docker image and you want to push it into a repository, it will authenticate using HTTPS. All right. So in order for that to work, you can just specify a variable, which is just a certificate variable. All right. You can just type in Docker underscore, all right, TLS. All right. We're trying to do TLS and then underscore SAT. dir. Now, this may look somehow, but of course, These are things that we're going to go into in the course of the class. So you don't have to bother about this. It's just a way for us to provide some kind of temporary certificates, all right, for our Docker image, for our Docker to run what we want, because it requires some kind of authentication. So we need to put in all of these parameters. So start. So I think that's all that we need to do. Now, before the script would run, of course, the same thing that we did here, right? The same thing that we did here, which is the before script, we also have to do the same thing here. So why do we need the before script? We want to authenticate into our Docker, all right? We want to authenticate, we want to connect to our Docker org repository right here, right? We want to connect to the repository that we have here, and we want to ensure that our GitLab is able to do that before we start pushing anything or start building any image, all right? So that's the first thing we want to do. So we are going to do the before script again. So before script, so what's the before script we want to do? We want to do Docker login, right? So we want to log in into a Docker hub. We want to be sure that Docker can, GitLab can communicate with our, so how do we now reference, right, the login parameters? Remember, we went to variables earlier, and then we specify some variables, username and password. So how do we reference them? Very simple. Just put -u. -u is just username, right? That's username. That's what it means. So your $sign is what you use to reference a variable, right? If you're a programmer, if you're $sign is just basically what you use when you want to reference a variable. And if I remember correctly, the variable we used was, let's go and look at it again so that we can type in the correct variables, right? So expand it. Okay, so the variable for the username is this, so we can copy this. All right, so variable is username, and then we paste that. Oops. Okay, so the variable is username, so that should be together. All right, so username, and so for password, we have our -p also for password, and then the variable, I think the variable is user_pass. We can verify this. Let's see. Yeah, so that's user_pass. So that's the variable. So the variable is right there. So we passed it in, and now we can now run our major script. All right, we can now run our major script. So we can now do script. We do our column, enter. So we do Docker. So what do we want to do? We want to build an image. Now, before we go further, let's look at our Docker file. Let's see what we're trying to build in the first instance. So let's go back to the repository. So we already have our Docker file defined. So if you look at it here, we have a Docker file here, and the Docker file is also using the same image. So it's going to use the same image to run our application. And so we have all of those things specified. So we mentioned, we talked about this Docker file in the last session. So basically, we are copying stores from one directory within our folder to another directory. And then within the container, once the container has been started, we are saying that it should run this requirement.txt file, and then it should run this PI, all these things. And then the port that the application is running on is port 5000. All right. So this CMD that you have here basically is that, when you run, all right, the image, the moment the image is run, anytime the image is run, then it should execute this command. All right. So basically execute this command and then allow communication to the application from anywhere. All right. That's what the 000 means. All right. So basically you're allowing communication to the application from anywhere and then on port 5000. All right. So that's basically what you're doing. All right, so now let's go back. So what were we doing? We're building an image. So we're building to -t to tag the image. So what is the image tag? What is the name? Now let's go back to our repository. So the repository we want to use is this. All right, so we want to use this repository here. We already have it right here. So we're going to copy this. All right. So let's copy that and let's paste that. So we are tagging it, and then we give it a name. So we call this Python app. So that's tagging. Now, that's not all. We need to specify our dot. So the dot there means, all right, the Docker file is present in this same directory. All right, that's what the dot is about. All right, so the next thing after the image has been built, of course, is we want to push it. We want to push the image. So you click on Docker push, and then you specify the same thing that you specified here is what you also specify. So copy and then paste. All right, so that's how that will go. All right, so now we have done the next step, which is building the image. All right, so we can commit this, and then the pipeline is going to run again if we commit this. So let's commit it and let's see if this works. Let's see what happens with this. All right, so pipeline build has been triggered, so we can build a pipeline from here. All right, so the pipeline is the image is building, so we can click on build image, and let's see the console output like we'll see in Jenkins, and let's see if this is going to run successfully. All right, so let's watch that. Let's watch. All right, let's see it's running. Wow, okay. So it looks like the job succeeded. So it's been pushed successfully. If you look at the pipeline, if you look at it here, let's look at the pipeline one more time. Let's look at it together. All right, so here we used, we masked our username and our password so that it will not be visible. All right, if you didn't mask it within this output here, your password and all that will be visible. Right, so that's why the masking was important. All right, so if you look at it here, we're able to build. So it told us that it was pulling the Docker image that was specified, right, in order to run what we needed to run. And then after that, we tried to authenticate into our Docker, and then it told us here that the login, it told us here that the login succeeded, so which means we're able to authenticate with our Docker up. And then we now try to build the image. Look at the command here. So because my username is masked, right? So you won't see the name here. So that's why the name was masked. So it won't show in the console output, all right, because the name is masked. So it was pulling, so it tells us, so it got this image, pulled the image. After the image has been pulled, then it now started, building our image, all right, the application into a Docker image. So all the dependencies were also installed, all right, within that same container. The same thing that we tested earlier. Remember, we did the make test, so it's also repeating the same process. And it tells us, okay, there's a newer version of pib, blah, blah, blah. Well, that's fine. So, all right, so everything ran successfully. And so from here, all right, it successfully tagged it. And then here is where the push, all right, started. So we pushed it to the Docker repository. So you can see docker.io/ right, the username that was specified. So in the console, the purpose of the masking is that in the console, your name should not, appear, or your password. So, and then it was successfully pushed, and then that's all that needed to be done. All right. So Docker and Docker, blah, blah, blah. All right. So everything ran, successfully. So if I go over here to my demo app, if I should refresh this, I should have my image right here in my repository. So there you go. It was pushed how many minutes ago? 3 minutes ago. Is our Python application right here. So that means what we did worked, right? So The next step now is to now, all right, send that application to our EC2. Okay, we want EC2 to run that application for us. So how do we go about that? Okay, so we're finished. Any question so far before we move over to the next phase? Do we have any questions, or are we all good? All right, so let's move ahead. Let's go back to our pipeline. And so from the pipeline, you can edit your script from the pipeline. So we have successfully run 2 stages and everything seems to be going on fine. So let's go to editor so that we can edit our pipeline script from there. All right, so these are pipeline scripts, so we can edit it from here. So now the next stage is to deploy, all right, our application to Amazon EC2. All right, we want to deploy our application to EC2. Okay, so we need to define that also. Right, so right here, we need to do another step. So that will be deploy. Oh, okay. Yeah, of course, definitely. The recording is going to be on the YouTube channel. So if you can watch it later on, again, all right, it's been recorded, so it's going to be posted there later today, right? So the next thing we want to do now is to deploy the image that we have, all right, that we have packaged. So we define another step again, and we call this deploy, all right, the deploy phase. Okay. So what are we doing with the deploy phase? We are simply pushing to, all right, EC2 instance. So again, we define the stage. The stage is what? Is deploy, right? Just the name deploy. All right. And then again, we are also going to have before script and then the main script. All right. Yep, the recording will be available. Yes, definitely. So now, again, don't forget also what we're trying to do now, we're trying to deploy to EC2. So the same way you authenticated, right, with your Docker Hub, you also need some form of authentication with your EC2, because GitLab cannot just, go to EC2 and say, oh, EC2 open up, I want to deploy something to you. No, GitLab should have some kind of credentials defined within it that gives it, you're right, the privilege to authenticate, all right, with your EC2 instance. Okay, so GitLab must have that privilege. So how do we authenticate to our EC2? All right, of course, SSH. So which means you have a private key file that is on your desktop. Okay, now the same way, just now I logged into my Jenkins server, right? And then you saw the command that I typed SSH-I, then I specified my key file and then my Jenkins details and all of that. So the same way, you must also provide that SSH details, all right, for your GitLab, so that GitLab can use that credentials to authenticate with your EC2. So how do we do that? Now, the first thing you want to do is to, all right, copy your private key. Okay, so let me open this hub here. I'm sure you can see this. So let me open a file. All right, so my file is right there on my desktop. So let me see, it should be somewhere here. DevOps. It should be here. Just a minute, let me look for that file. I think I saw it on my desktop just now. All right, it's here, so why is it hiding? Okay. Desktop, so the file is this, okay. Hold on. Oh, okay. All right, so Yeah, this is the file that I'm looking for. So now I need to copy this old file, all right? I need to copy this. This is my private key file. So copy. And then I will go back to my, all right, Jenkins, sorry, I'll go back to my GitLab CI. Okay, yeah, so let me go back to here. Now, remember when we wanted to create a variable, right? The username and the password variable went somewhere. So we're going to go to that same place, which is settings. We go to, settings, we go to CICD, and then we go to variables, all right, variables. And then here we had a variable, right? We're adding another variable, okay? So how do we add this variable, okay? So let's see how that works. All right, so we need to add the variable here. So the same way, we're going to give it a name, all right? So let's call this SSH underscore key, all right? So that's our SSH key. And then the value is what we need to paste in right here, all right? We need to paste it in here, okay, under the value. We need to paste that in. And of course, we need to protect it. We can also mask it. Okay, it's telling us that this variable cannot be masked. All right, so we can uncheck that. And then we need to also specify the type. Is it going to be a variable? Is it going to be a file? All right, because this is more than just a single variable. All right, because it's not a password, it's not a username. All right, so it's going to be like a file, right? Okay, so we need to choose a file for this one because it's what we have there. It's more than what a variable. A variable should just be maybe like a single thing, but then this type now, it's not a variable type. It's going to be type of a file. So let's see, we can mask it. So that's okay. So we protect it. We can also expand it. That's fine. So once that is done, we can click on add variables. So that will also add our SSH key, all right, to our variable section here. So once that is done, we can go back to our pipeline. And then we can start building a pipeline. Now, if you have done anything on EC2 before, you understand that before you can use your SSH key, right, to authenticate, you need to change the permissions on that SSH key, all right, to 400. So 400 basically means it should only be read-only, right? So what we want to do now is that we want to make that SSH key that we are provided, we want to make it read-only, all right? That's what we want to do. We want to make it read-only, all right? So that's where the before script for this comes into play. So before script, so we run a command, a Linux command. So change the mode 400, and then we specify our variable. So SSH underscore key. All right, so we are trying to what? Change the permission for that file so that the file only becomes readable. All right, we don't want anybody to be able to edit it or tamper with it. We want to make it just readable. All right, now, so let's run the main script. So the script, so the first thing we want to do, of course, obviously, is to SSH into our EC2 instance. All right, now, if you notice, when I was trying to log in into my Jenkins EC2 instance earlier, it was asking me some kind of questions. Do I want to proceed? I had to say yes and all of that. Now, GitLab may not be able to do all of that for us, so we need a way to bypass, all right, that system. We need a way to bypass that system so that it doesn't ask us whether yes or no, do you want to have the fingerprint, all those things that SSH asks you. So you need a way to bypass it. And then I'm sure we did that during the Jenkins class too. So I put -o, and then I type in what you call strict. All right, strict host key. All right, instead of checking the host key, that's not necessary. So don't check the host key. Strict host key check-in. And then we set that to no. All right, so which means we're saying don't check anything, just allow this thing to move on and we're fine. So the same way you authenticated on my system earlier, I'll also specify that, and then I'll specify my SSH key. All right, specify the key name, and then what's the name of my EC2 instance? My EC2 is my Docker EC2 instance. The username is EC2-user. Is that it's an Amazon Linux server. So this is my EC2. So I'll copy the public IP address, and then and then I'll put in the IP right there. All right. So that's what I need to do. Now, again, don't forget, there's one more thing I need to do. I also need to, from my EC2 instance now, I want to connect, with my Docker. All right, I want to connect with my Docker orb in order to pull, the image that we just published so that that image can run on my system locally. All right, so we need to do all of this. Okay. All right. Now, there are certain things that we also need to know, which is that now this SSH that we are running right here is actually something that is, this SSH, every other command will actually be after this SSH command. So you need to put them, under it. So we put in our, what do you call this now? Apostrophe, right? And then I press enter. So basically what I'm trying to say, or what I'm trying to do, is that all the other commands that I'm going to run after the SSH, they fall under the SSH, all right? So I'm going to, do the indentation. So let me just tap that, okay? So from here, we can begin to type in our Docker commands. So Docker, again, we want to do Docker login because we want to pull, the image that we just published there. We want to pull it, to our EC2 instance so that our EC2 instance can run that same image. So that's username, right? So username, and then the password -p. We'll type that in user_pass. Okay. And then the next thing we want to do is that we want to run additional commands, and that's where this sign comes in. Is actually a Docker command sign. So we want to run additional commands, so we can press enter, and so we do Docker. All right. Okay, so we're doing Docker run. So we want to run the image. So the image has been pulled. We have authenticated into a Docker orb. All right. The next thing we want to do now is to run that image, right? So we do Docker run. All right. So -d. So to run the -d, that means run in detached mode. We don't want it to create a unnecessary log on our system. So we want to run it in the background mode. All right. That's what the -d there would do for us. So remember earlier, the port we saw was 5,000. So we specify that same port, 5,000. All right, so port 5,000. And then, so what's the image name now? So the image name is this. So we can copy this. All right, we can copy this and paste it. So what we're saying is logging into Docker. All right, once you're logging into Docker, run this particular image on port 5,000 for us. Now, before we go ahead and commit this, we need to do a few things on our EC2 instance, right? We need to do a few things on our EC2 instance. Yeah, so we're using the SSH to log into our EC2 instance. Now we have an EC2 instance here, which is our Docker image, all right? So the reason why we're using the SSH is to log into this Docker server, all right? This Docker server has a Docker runtime installed on it that we're going to see shortly. So let's log into this Docker server and let's see what we have there, all right? So let's log into the Docker server. So let's create a new shell script here. So we're simply going to call this Docker. So let's call this, so we call these Jenkins. See, so just to identify them. Okay, so let's change directory to desktop. All right, so the SSH we're asking is to authenticate into our server, right? We have a server, we want to log in into it and do some operations. That's where your SSH comes in. So SSH-I, then the key. All right, my username for my server is -this @ all right, I think I copied it already. Yeah, so that's the username. So enter. All right, now what we have in our script that we say script host key checking equals to no is actually this, because if you want to log in, it asks you all of this. So if you don't put that condition there, then it means that your pipeline is going to get stuck at this point because it's not going to be able to move ahead. So I'll just say yes. GitLab cannot type yes for me. All right, so I need a way to to bypass it, and that's why we have the street host key checking turned to no. All right. So we have Docker runtime installed already. If you go to the Docker page, you can see how you can install it. So Docker is already available on this machine. All right, but then we want to check a few things, right? So Docker ps-a. Okay, it looks like we have a few container running. Now that's okay. That's fine. As long as it's not the container, it's not the same ID as what we want to run, that's fine. So let's look at Docker images. What do we have there? Okay, we have some images as well. That's fine, that's okay. So Docker runtime is available, all right? So we've confirmed that. Now the next thing we want to confirm is, now remember, we are opening up port 5000, okay? So we want to ensure that that port is opened up in our security group on the cloud environment, right? We want to ensure that the port is open. So if I click on my Docker server again and I go to security, this is a security group that I have attached to my Docker server. So port 5000, oh, okay, it looks like I have it opened already. So port 5000 is opened up already. So that's fine, it's opened up. For somebody that may be wondering, so how do you open up all these things? You can just go to here. If you're familiar with AWS, you can go to your security group right here. And then you can create a security group on here, right? You can create a security group here. Give it a name. Let's say this is the name, give it a description, and then choose your VPC, add your rule. So in our own case, the port is 5000, and then we want anybody from anywhere to be able to access it. Once that is done, you can save changes, and then your security group is created. So port 5000 is open on our own end. So it looks like we're good to go. All right, so it looks like we're good to go. So from this point now, we can commit this changes, and then it's going to run the pipeline for us all over again. All right, so let's commit it. And let's see what is going to happen. Okay, it's telling us checking pipeline status. So let's view the pipeline. Now, if you observe something, you will see that the pipeline was, it started from the build image again to run test to deploy. All right, it started from the, that stage again. Okay, so we're going to see how we can, we can put this, in a kind of a correct order. All right, so instead of doing the build again and the test again, you should just go ahead and do the deployments, right? So we're just going to see shortly how we can streamline all of this and how we can do some kind of variable as well. Okay, so the build image has been successful. All right, so automatically the test is running. Okay, so the build is successful. So the test stage is running at the moment. So you can go to JobSpark. You can see that it's still running. Okay, so let's go over here. Okay, so that also ran successfully. So let's go to pipelines. Let's see. So the third stage is running now. So this is the deploy phase. So you can click on that and see what we have going on. Okay. Wow. That was fast. It looked like the job succeeded. Whoa, whoa, whoa. You can see that the thing it uses the, can you see here? It uses the default image. You know, I told us that the image that the runner uses is Ruby by default. So because we didn't specify any image that we want to use, we didn't specify any, base image, right? It just uses the Ruby image automatically. Okay. So this is to tell you, just to confirm what I said. So it uses the Ruby by default. So if you want to override that, then the best thing is to provide your own, image. So you can see that, everything runs successfully, the chmod key, all right, the Docker login, all those stuff. You can see the warning permanently added. So at this stage, it was supposed to ask us to say yes or no, but because of this parameter that we have passed in, all right, we are able to bypass that. Okay, so, and it tells us that, oh, okay, the image could not be found locally, and then so you have to pull it off, all right, from Docker hub, and then the image, all right, is running on our EC2 instance. So how do we verify that image is running? Let's go and see. If you go back to your Docker hub also, you should be able to see that the image was pulled from the Docker hub repository. You should have that information also there. So you can see pulled 2 minutes ago. All right, it shows us that it was pulled 2 minutes ago. So that's some good information. So now let's go to our EC2 instance. Let's go and verify if truly our application is up and running. We need to verify that information. So this is the IP address of our server. All right, so the first thing I want to do to verify is to go back to my page here where I logged into my Docker server. So if I do Docker PS, so Docker PS is just to say I want to view, running container. So Docker PS. All right. So you can see it looks like the thing worked. It looks like it's run correctly. So if you look at it, Python app. All right. The port is open 5,000. Blah blah blah. Okay. So this shows us that indeed GitLab was able to deploy that image on our EC2 instance, and the image was run by GitLab for us automatically. All right, so let's go and verify if our application is visible or not. So let's copy the IP address and then put a column 5,000, and let's see what we have. Whoa. So there you go. Your Python application is up and running. If you click on info, that will show you a few information about your EC2 server. If you click on monitor, you can see your performance monitor, how your system is doing, the CPU usage, the memory usage. All right, so there you go. So that's GitLab CI/CD. That's the same thing Jenkins would do, but of course, GitLab CI/CD can also do the same thing. So we can see that, GitLab is a bit, simpler, all right, compared to Jenkins. And, we didn't have to install any plugin in order to use our GitLab. Everything was simple and was easy along the way. All right, so let's do some, some kind of abstraction, right? So let's go back to our GitLab. Let's go back to our GitLab. Let's go back to our pipeline, and let's just clean up our code a little bit. All right, I just wanted to show something. Let's clean it up a little bit just to give it some kind of, let's define some variables. So like all of these, names that we have here, we could actually use variables, all right, to map all of these things. We don't have to necessarily, specify the names and all that. And then all these stages, we can actually put them in, the necessary stages that it should be. So how do we do that? So let's create a variable. So here you can define variables. And then, so the variable, the image name, for example, I can define image name. So the image name here will be this. All right, so this will be the image name. All right, so that's the image name. And then I can also specify the image tag. All right, so what's going to be the tag? The tag obviously is this. Okay, so that's the tag. And then I can put that here. Also, I can also specify the EC2 ID, all right? Can specify that. So instead of coding my EC2 login here, I can just copy it and then put it right here. All right. So that is what that is basically creating the variable. And then all of these stages that we have here, we can also define a stage for them. All right. We can do stages for them. And then we have the test stage, we have the build stage, all right, and then we have the deploy stage. Okay, so that's the sequence we want you to follow. We want you to follow the sequence. So the first thing we want you to do is to test, to build, and then to deploy. All right, we want you to follow that sequence. We don't want you to build just anyhow. All right, so now here we can begin to now use our tags. So for example, here I can just, instead of using this, I can decide to just reference, write my image underscore name, and then this will be, all right, image underscore tag. All right, so the same thing is going to apply here. So I can copy this and replace it with this. All right, so that's creating a variable for it. And then here I can also do the variable. So that will be EC2 underscore ID, right? Right. So that's just using variables for all these things. Now, before you go ahead and commit this, let us, all right, let us stop the container. Okay, so we can copy this. Okay, so let's stop it. So let's do Docker stop. Docker stop. So we stop the container. So if I want to remove it, I can do contain docker rm, and then, all right, I can just call it up again and then do docker rm to remove the container. So docker images. I can also remove that image as well. All right, so I can copy this. Okay, so target, so that's the Python app. So what I want to do is to remove this image. So just do docker RMI. RMI is to remove the image. So the image has been removed. All right, so we can go ahead now and commit this, all right, changes that we have done. So let's see if, how this would be different from what we did earlier. So let's commit changes. So the pipeline syntax is correct. So let's view pipeline. So now we can see that we have a more, so you can see that everything is running sequentially. So the test will run first, and then once it's run, it can build the image, and then it will deploy it. So everything is going to follow that same sequence. So you can see that all the jobs have been created, but this one is running first, and then this one will run next, and then this one will run after. Right. So that's just a way to create, some kind of order for your Jenkins. Sorry, why do I keep saying Jenkins? For your GitLab pipeline. All right. So that's that about it. All right. The YouTube page is this. Let me just type that in again. YouTube.com/ So that's the YouTube page. The video will be posted there tomorrow. And also, you can also connect with us. The class is going to be starting pretty soon. We're starting on the 31st of, So I'm unmuting all of us. So if you have any questions, you can ask your questions. I'm trying to unmute everyone so that people can ask questions. I'm coming. I'm going to answer that question. I'm trying to just, unmute people so that people can talk. Okay, so let me see. I have a little bit click with which script I try to go to the Java engineer. I am now having. Okay. Okay.
Hello, sir.
All right. Now to answer this question.
Hello.
Yeah, please. Okay. I want to
Can you
answer.
hear me?
Yeah, I can hear you.
Okay.
Please just allow me answer. There's a question that I just want to quickly respond to in this chat section. All right.
Okay.
We have a training that is coming up. Actually, we're using the NAS IO platform. I think the Python app should be running now. Okay, so you can see that the thing has been deployed again. So we have a training coming up on, next week, Wednesday, starting next week, Wednesday. It's actually a class. So we have this, yep, where is it again? All right, so this is the page. So if you want to join in, you can just go to that page and then register. You can, of course, you have to pay. It's not a free class. The class is actually $2,500, right? But then you can do maybe 500 every month. I think we've reduced it to that amount. So you can also do that. All right, 500 every month. So let me just put the link there. So for those who are interested, you can go there to, connect with us for the class if you're interested in the class. All right, so that's the link to the site, and that's why we sent out, a broadcast email this evening as well, so that people can be aware of what is going on. So you can go there, register, make your payments if you're ready for the class, and then from there, we take it up. All right. Okay. Somebody was trying to ask a question. Please go ahead. The duration of the class is 5 months. And it's going to be a 5-month class because DevOps is not something you can learn within just a month or two, right? So it's going to be a 5-month class. Yes, the code is going to be on my GitHub repo. I'm going to push it to my GitHub shortly after now. And then the video will be posted on the YouTube page as well. So you can get a code from there. You can get the GitHub repo as well. Please go ahead, sir. Please. Sorry for. Go ahead, please.
Thank you very much for your content. I think it's very great and it's a great resource. So I was just wondering if a consulting firm wants to hire or get you to train like a fellow DevOps engineers, would you be open to that? And
yeah, sure, that's possible. That's possible, sir. Hello?
Okay, yes, that sounds good.
Yeah, that's possible. So you can, I think you're on the Telegram group, right?
Yes, I am. I'll contact you.
All right, so you can reach out to me privately so we can take it off from there.
Thank you, sir.
All right, thank you very much, sir. All right, so any other questions? The class, we're done. The class already, so the pipeline is running on GitLab. So everything runs successfully. Okay, also can Yes, somebody that does not have an IT background can join the class, absolutely. And that is why we're starting from the very scratch. We're not starting from, there's a lot of discussion going on, there are a lot of, now DevOps is just, different tools, right? And so people are saying, okay, I want to learn Kubernetes and all that. We're not starting from all those high-level stuff, right? We're starting from the basics, which is Linux. So we walk you through Linux, because if you look at what we have done today, we've run, several commands, right? chmod, make test, and all those things. So all those things are, Linux related stuff, right? So even if you don't have a background in IT, all right, if you can take the training, start from the very basics, and then of course you also have to commit, certain number of hours to it as well. Because what I tell people honestly is, the trainer is going to do his own job, right? And of course, for me, I tell people there's no school that is bad, right? It depends on the student entirely, right? So the class is going to be 3 hours, but of course, you as somebody that wants to learn as well, you must have at least, that's what I tell my student, I encourage, people, at least you must have like 2 hours minimum, all right, every day that you can commit to, all right, the content, so that, if you do it yourself, that's where the confidence, comes from, all right? Because if you just, maybe after the class, you don't take it up again, it won't stick that way. But show people, right, this is the real stuff that you do in a real world environment, all right? So yeah, it's possible. So even if you don't have a background, it's possible that you, all right, join the class as well. Okay, actually, the person all right, it's okay. Even if you find yourself between operations and development, all right, you can still, if you want to be a part of the class, it's okay, you can join. Like I said, the link has been sent to us. You can go to the nas.io/DevOps Acad. If you're ready for the class, you can, click there, and then, you can take the conversation from there. Right, so you can start from there. A lot of people transitioning to DevOps. There are software developers moving to DevOps. We have network engineers, system administrator. DevOps is actually just a philosophy, all right? It's something that works in any system or any organization. Now, let's break this DevOps thing down a bit, right? Number one, DevOps is a philosophy. Okay. Now let's look at it like this. Before, automation started, let's look at a simple factory. Now, maybe a factory where they produce pizza, for example. Now, initially, they needed a lot of human beings, right? People that will, mix the flour, do the baking, all those kind of stuff, all right? But some people came up with the idea that, okay, we can have some machines that can do flour mixing for us, all right? Instead of having humans do that, okay? So somebody came up with a machine. So now there's a machine that can mix flour, all right? Another person came up and said, okay, we can have a machine too that can do certain things for us and all that. So they started, having different machines. So now, if you want to produce a pizza, you don't necessarily need to put anybody, just, put in the flour. There's a machine that will mix, there's a machine that will bake, there's a machine that will add, the sauce, there's a machine that will do this. So DevOps is just that philosophy, right? It's just a philosophy. Like, okay, the philosophy is just that, okay, we want a way by which we can automate our processes, all right, so that we can reduce errors, as as you want to reduce to near zero level, right? So that's just what DevOps is about. So the same thing you have in a factory where they are producing soft drinks, they are producing stuff like that, and then they have machines that will take the bottles, clean the bottle, and then there's another machine that will put the content in the bottle, there's another machine that will cork the bottle, there's another machine that will, package, all right, all those products and all those kind of stuff. That's just what DevOps is about. It's just about automating every process, all right, of the software development lifecycle. All right, so it's just a philosophy. So within that philosophy, you now have different tools that you have to learn, that you have to know, that can help you to achieve, all right, that automation that you want. And that's why for different organizations, they have different tools that they use. Some can say, oh, okay, we are using Jenkins. Some can say we are using GitLab. Some can say, oh, we need somebody that knows Kubernetes. Some can say we need somebody that knows Terraform, somebody that knows CloudFormation and all those kind of stuff. All right. But then the DevOps thing is just a philosophy that cuts across several organizations. All right. Before, banking became what it is now, that I can sit in my room and transfer money to somebody anywhere in the world. All right. Initially, before you have to go to the bank, you have to fill up a teller, then you give it to the teller, they have to process it, and then after some time, your money will go right to where it's going. Or before the issue of email came about, right? You have to go to a post office, right? Give them your letter, whatever it is you want to send, and then you won't even know whether the mail got delivered or not. All right, but then somebody came up with the idea of email to say, okay, let's automate this thing. Instead of going to the post office, I can sit down with the system, type an email, put the email address, send it, and the person receives it, and the person can reply me back almost immediately. All right. So it's just the same thing with DevOps, right? Software development has followed a particular pattern. There were errors, there were issues. Now we are trying to now see how can we build softwares more effectively, all right, using an agile method, right? That's just what DevOps is about. So all these tools are things that you will learn, and then you can become a DevOps engineer. And then you can now, after you become a DevOps engineer, you can now decide to specialize maybe on Kubernetes. Maybe you just want to be a Kubernetes expert. And of course, it's still part of DevOps anyway. All right. So any other questions before we, let me stop the recording.